Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Assign CIP priorities to the 4 substituents of the chiral center in cysteine, H2NCH, CH2-2. Priority 1. NH2, nitrogen directly attached, atomic number 7. Priority 2. Cu, carbon attached to 2 oxygens, O phantom atoms give high priority. Priority 3. CH2, carbon attached to S, sulfur has atomic number 16, but first atom is C bonded to S, H versus Cu, first atom C bonded to O, Cu ranks higher than CH2. Weight sulfur, Z is equal to 16, versus oxygen, Z is equal to 8. For CH2, the first atom on the chain is C, bonded to S, H. For Cu, the first atom is C, bonded to O phantom. Comparing OS, H. No sulfur, 16, oxygen, 8, so at the second shell, CH2's carbon has S attached, which outruns Cu's carbon with O attached. Therefore, corrected priorities. Priority 1, NH2, N, Z is equal to 7. Priority 2, CH2, first atom C, attached atoms S, H, S has Z is equal to 16. Priority 3, Cu, first atom C, attached atoms O has Z is equal to 8 but 3 oxygens. Duplicated atoms rule, O versus S, H, compare highest first, S, 16, O, 8, so CH2 Cu. Priority 4, H, lowest. So, 1 is equal to NH2, 2 is equal to CH2, 3 is equal to Cu, 4 is equal to H. The image labels 1 is equal to NH2, 2 is equal to CH2, 3 is equal to Cu, 4 is equal to H consistent with above. Step 2. Determine configuration, R or S. The lowest priority group, 4, H, is on a bold wedge, coming toward the viewer. This means H points toward us, which is opposite to the standard requirement, lowest priority pointing away. Looking at the structure, H is on a wedge bond toward viewer. The curved arrow from 1, NH2, to CH2, 3, Cu as drawn in the image goes counterclockwise. The arrow sweeps from left down through bottom to top CCW direction. Since the lowest priority, H, points toward the viewer instead of away, we must reverse the observed rotation. Observed rotation, CCW, S. Reversed, CW is equal to R. Therefore, the configuration is R. Step 3. Assign D or L. The DL system is based on the Fischer projection convention relative to glyceraldehyde. In a Fischer projection of an amino acid, the amino group on the left corresponds to L configuration and on the right corresponds to D configuration. To determine DL, orient the molecule in a Fischer projection with the Cu at top and CH2 at bottom, vertical chain away from viewer. In the given structure, NH2 is on the left side. In the standard Fischer projection of L amino acids, the NH2 group is on the left. Therefore, this structure is L. Note, although cysteine is R in the CIP system, unlike most L amino acids which are S, it is still classified as L in the DL system because the priority order of substituents in cysteine is unusual due to the sulfur-containing side chain elevating CH2 above Cu in CIP ranking, while the DL system does not use CIP rules. Therefore, the correct answer is A, R, B, L. The correct answer is shown on screen.